Welcome to another episode of Forge Diaries. Today I will show you how to rebuild the Propane Forge, an activity I have to engage in about once a year. When I create swords, I often forge weld different types of steel to create visually interesting patterns. If you have watched some of my videos, you know exactly what I mean. The flux for forge welding is very aggressive and over time slowly destroys any forge. What you see here is a forced air propane forge. At the bottom, the blower supplies pressurized air, the propane and air combine in a mixing chamber, and the tapered nozzle shoots the mixture into the forge chamber where it combusts and generates heat. This is probably the 5th or 6th time that I'm rebuilding this forge. The main chamber was a propane bottle originally. The forge is 12 inches long and has a diameter of 12 inches too. Since forge welding is so hard on the forge, it's important to have a setup that can be repaired easily. What you see here is the system that has worked the best for me. The shiny black material on the floor is borax slag, but as you can see, the constant heat itself is another factor for internal breakdown. Let's go back to the anatomy of my forced air propane forge. The burner enters the forge chamber at the top and causes the flame to circulate. To maintain forge welding temperatures, heat efficiency and thus insulation becomes very important. I'm using 2 inches of ceramic fiber blanket and a thin layer of high temperature refractory mortar on top to protect the fiber blanket. My favorite refractory mortar used to be Saturnite, and ceramic fiber blanket that was rated at 2600 Fahrenheit, that's 1023 Celsius. However, these are difficult to get, so this time we are trying something different. Tony and I visited a local pottery supply store, Clay Planet, that was super helpful and bought all materials there. I will describe all of them as we start using them. As we are doing the rest of the cleanup, let's take a closer look at the burner. It's heavily influenced by Tim Sowada's forced air manifold. Check it out at tzknives.com. The main difference is that I prefer to use a ball valve over a gate valve to regulate propane flow. The ceramic fiber blanket we found was 2 feet wide and roughly 1 inch thick. To figure out the length, we do some very simple math. 2 pi r for the circumference of a circle, accounting for the thickness of the material. A word of warning, ceramic fiber blanket contains a lot of sharp little fibers. You don't want them on your skin and you don't want to breathe them in. We are not wearing appropriate protection and are trying to make do with a fan to keep the fibers out of the air around us. Since the blanket is 2 feet wide, that's 24 inches, and the forge chamber is 12 inches long, we can cut it in the middle to get 2 layers of heat insulation. This fiber blanket is rated at only 2400 Fahrenheit, that's roughly 950 Celsius, and would quickly break down at the temperatures I'm running my forge at. The hope is that the refractory mortar will provide a little bit of protection. Cutting the material is challenging and much slower than the time-lapse makes it appear. Another way to prevent the fibers from going airborne is to wet down the ceramic fiber blanket. In this case, we also bought some rigidizer, which increases surface hardness and supposedly also protects against erosion. As time always tends to be limited, I usually try to put off fixing the forge as long as possible. In this case, Tony was visiting again and we decided the time had arrived on the spur of the moment. That is also the reason why we did not have masks or long-sleeved shirts. Once the rigidizer has been applied, we need to get the blanket through the opening of the forge chamber and then slowly spread it out so that it hugs the inside surface and does not have any overlapping areas. This operation would be somewhat more difficult if the blanket had not been wetted down. With the rigidizer applied, it stays in place where I press it. The next challenge is to create a hole for the burner. I'm using the outside tube to guide the screwdriver through the blanket. Where it comes out, I can cut an opening with scissors. Now that the first layer of insulation is complete, it's time to start on the second one. The process is very similar. The main difference is that the inside radius is smaller and we need less length. When I first started forge welding about 8 years ago, I was using a commercial propane forge. I remember the day when the first drop of liquid borax ate straight through the forge shell. Since then, I have always made my own forges, especially when forge welding there's not really any way around that. Also, building a forge yourself makes the notion of slowly destroying it much less scary. It's just part of the business. Spreading out the second layer of insulation is a little bit more challenging since we cut it somewhat too long. As with the first layer, I need to cut a hole at the right location for the burner nozzle to fit through. Since there is less room for navigation now, getting in the scissors takes some time. Now that the insulation is in place, we need to coat it with a layer of high-temperature refractory mortar. This mortar is usually meant to hold fire bricks together and is not really made to coat a forge. My refractory mortar of choice is Saturnite, which is rated to 3000 Fahrenheit, that's about 1180 Celsius. However, it's difficult to find, and the clay store had a different product called Smooth Set, which is rated to 2900 Fahrenheit. I have never used this product, and it's going to be interesting to see how it's going to hold up in the forge. In the meantime, the mixture ratio of mortar to water is pretty similar to Saturnite, roughly 3:1. The application of the mortar is pretty straightforward. The goal is to coat all of the ceramic fiber blanket, and that's really all there is to it. The mortar is very dusty and easily airborne. The fan also helps somewhat with keeping it out of our lungs. The round form of the chamber helps with coating even the ceiling without the wet mortar dropping down. It also somewhat sticks to the fiber blanket, which also helps. Although all of this is pretty straightforward, it still takes a fair bit of time. Including getting the supplies, we probably spent about 4 hours on this whole procedure. As I mentioned before, the liquid borax is quite aggressive and quickly eats its way through any material. For that reason, I also like to put a sacrificial floor into the forge. It would be best if it actually fit the whole length, but in this case we did not have enough half-thick fire brick and had to do with the material at hand. Alright, this took quite a while. The only thing remaining is to get fire bricks in place to create openings on both sides of the forge. The fire bricks are another experiment. The shop had high temperature insulating fire bricks left over from a previous job. They are rated at 3000 Fahrenheit and so should not melt even when forge welding. On top of that, they look really pristine and pretty. As you may hear, the blower is running already to help out with drying the mortar. The whole procedure for curing it requires slowly cycling up the temperature, and the air is the first step in that. I will usually run the burner for an increasing amount of time, starting with just a few seconds till I work my way up to a couple of minutes. At that point, the forge is ready to use. Alright, that's it for now. I hope you enjoyed watching us take a destroyed forge and transforming it to pristine condition. If you are still watching after all this time, there's one thing you probably really want to do now, and that's to subscribe to my channel. It's easy, just click below where it says subscribe. You know you want to do it, so just do it. It's much easier than it seems, go ahead and try it. If you are subscribed already, try subscribing again or hitting the like button or all of the above. See you next time.